Let's get the most dramatic part of that headline out of the way immediately, because no volcano on Earth, no matter how big, has ever cracked a planet open, and none ever will. That's not how volcanoes work. That's not how planets work. And if you clicked expecting some kind of world-ending geological event, you're about to get something far more grounded and honestly, more genuinely fascinating. What's actually true is that Earth's biggest active volcano is real. It's sitting quietly on the big island of Hawaii right now, and it has been slowly, patiently refilling itself with molten rock for years. That part of the story is completely real and worth understanding properly. So let's talk about what Mauna Loa actually is, what its current status genuinely looks like as of this year, and why, even when it does eventually erupt again, the planet is going to be just fine. First, let's establish exactly what we're talking about, because the title of biggest volcano on Earth gets applied a little loosely depending on which specific measurement you're using. If you're measuring by sheer underwater volume and footprint, an enormous, entirely extinct underwater volcano called Tamu Massif, sitting deep in the Pacific Ocean, roughly 1,000 miles east of Japan, actually claims that title. An absolutely colossal shield volcano covering an area roughly comparable to the state of New Mexico, though it hasn't erupted in millions of years and poses precisely zero risk to anyone. Tamu Massif is actually part of a much larger underwater plateau, and when researchers first proposed back in 2013 that the entire structure might represent a single, unified volcano rather than a cluster of separate ones, it briefly held the title of largest single volcano ever discovered anywhere in the solar system, only for follow-up research a few years later to reveal that Tamu Massif was likely built from multiple separate eruptive centers over time rather than one single point source, a genuinely humbling reminder of how much even something this physically enormous can still remain scientifically uncertain and actively debated among researchers studying it. But when people talk about the biggest active volcano, the one that could genuinely still erupt again, they're almost always talking about Mauna Loa, and that distinction matters a lot here. Because Mauna Loa isn't some sleeping ancient relic. It's a fully active, monitored, occasionally erupting volcano that most recently sent lava flowing across the landscape just a few years ago. Mauna Loa is genuinely staggering in scale once you actually break down the numbers. It makes up roughly half of the entire landmass of Hawaii's Big Island, and if you measure it the way geologists actually measure mountains on Earth, starting from the ocean floor rather than from sea level, it's actually taller than Mount Everest, rising nearly 30,000 feet from its base on the Pacific seafloor to its summit, even though only about 13,780 feet of that total height pokes up above the waves where we can actually see it. To put its sheer bulk into perspective, geologists estimate Mauna Loa's total volume at somewhere around 18,000 cubic miles of accumulated volcanic rock, making it, by volume, roughly 100 times larger than a familiar, similarly iconic volcano like Mount Rainier in Washington state, a comparison that helps convey just how much this single mountain genuinely dwarfs most of the other volcanoes typically featured in disaster documentaries and clickbait headlines alike. Because so much of its bulk sits below the waterline, Mauna Loa's own sheer weight is genuinely reshaping the ocean floor beneath it, causing the Pacific tectonic plate it sits on to slowly bow and slump downward under the sheer mass of accumulated volcanic rock, an almost unbelievable illustration of just how much material is piled up here over the volcano's roughly 700,000-year history. Mauna Loa is what geologists call a shield volcano, an understanding that classification is genuinely important for correcting the scarier misconceptions floating around online about what an eruption here would actually look like. It also helps to understand exactly why a volcano this massive exists in the middle of the Pacific Ocean in the first place, thousands of miles from the nearest tectonic plate boundary, since most of the world's volcanoes form along the edges where two plates collide or pull apart. Hawaii's volcanoes instead sit atop what geologists call a hotspot, a stationary plume of unusually hot rock rising up from deep within Earth's mantle, essentially a fixed blowtorch sitting beneath the slowly moving Pacific tectonic plate. As that plate has drifted steadily northwestward over millions of years, it has carried a whole chain of now extinct, eroded volcanic islands away from that stationary hotspot, leaving behind the entire Hawaiian island chain like a trail of footprints, with each island representing a snapshot of where the hotspot happened to be sitting at that particular point in geologic history. The Big Island, sitting directly above the hotspot right now, is geologically the youngest island in the entire chain, and it's precisely why it hosts not just Mauna Loa, but several other active or recently active volcanoes as well, all currently positioned directly over that same underlying source of rising magma. Shield volcanoes get their name because their broad, gently sloped profile resembles a warrior's shield laid flat on the ground, and they form specifically because the lava they produce is extremely fluid and runny, allowing it to spread out over huge distances in thin layers rather than piling up steeply the way a more famous, cone-shaped stratovolcano like Mount Fuji or Mount Vesuvius does. That fluidity is the single most important detail in this entire story, because it's exactly what determines how a Mauna Loa eruption actually behaves. Unlike the explosive, ash-spewing eruptions people typically picture when they hear the word volcano, a Mauna Loa eruption is almost always what volcanologists call effusive, meaning lava simply flows out, sometimes dramatically, sometimes even producing spectacular fountains hundreds of feet tall, but without the violent, pressurized explosions and choking ash clouds associated with volcanoes that have thicker, stickier magma trapped under far greater pressure. The chemical difference driving all of this comes down to silica content. Mauna Loa's basaltic lava contains relatively little silica compared to the thicker, more viscous magma found in explosive stratovolcanoes. And that lower silica content is exactly what allows gases trapped inside the molten rock to escape gradually and gently as the lava rises, rather than building up the kind of catastrophic internal pressure that eventually triggers a violent, explosive blast. It's genuinely the same basic chemistry that separates a gently fizzing glass of soda left open on a counter from one that's been shaken vigorously before opening. The gas is going to escape either way. The only real question is whether it leaves calmly or violently, and Mauna Loa's chemistry has consistently favored the calmer version throughout its entire recorded eruptive history. So what's actually happening at Mauna Loa right now, as of the summer of 2026? The honest, current answer, straight from the U.S. Geological Survey's Hawaiian Volcano Observatory, is genuinely undramatic. As of the most recent monthly updates, the volcano alert level for Mauna Loa remains at normal, and the volcano is not erupting. Seismic activity actually decreased slightly over the course of June, and while there has been continued inflationary ground deformation at the summit, meaning the ground has been slowly rising, that inflation has been happening at a consistent, steady rate for the past several months, a process scientists explicitly attribute to the gradual refilling of Mauna Loa's summit magma reservoir following its most recent eruption, which happened back in late November of 2022. Gas and temperature readings from monitoring stations on the volcano's southwest rift zone have shown little meaningful change relative to previous months either, sitting comfortably at what USGS scientists describe as background levels. In plain terms, Mauna Loa is doing exactly what a shield volcano does in between eruptions, slowly, patiently recharging itself with fresh magma rising up from deep within the earth, a process that can quietly continue for years or even decades before building toward another eruption. It's worth walking through that most recent 2022 eruption too, since it's genuinely the best, most recent real-world example of what a Mauna Loa eruption actually looks like in practice. And it stands in sharp contrast to the apocalyptic framing suggested by a headline about cracking the planet open. Mauna Loa began erupting shortly before midnight on November 27, 2022, when lava emerged from fissure vents inside its summit caldera, marking the volcano's first eruption in 38 years. Over the following days, the eruption's activity shifted into Mauna Loa's northeast rift zone, sending lava flows advancing across the landscape, at one point coming close enough to threaten the Mauna Loa Observatory and the Cross Island Saddle Road that scientists and residents watched the situation closely for a tense stretch. Thousands of nearby residents received advance warning as monitoring instruments picked up increasing seismic activity and ground deformation in the weeks leading up to the eruption, giving both scientists and the general public real, meaningful lead time to prepare, rather than being caught off guard the moment lava actually broke the surface. Once the eruption began, USGS scientists provided continuous public updates, including regularly refreshed maps tracking exactly where lava flows were advancing and how quickly, information that allowed both emergency planners and curious residents alike to follow the event's progress in close to real time throughout its roughly 2-week duration. But by the time the eruption officially ended on December 10th, after just under 2 weeks of activity, the total damage came to an estimated $5 million in property impact, with 0 recorded injuries or fatalities. Compare that to the genuinely more destructive and disruptive 2018 eruption of Mauna Loa's smaller neighboring volcano, Kilauea, which destroyed around 700 homes in the Puna district, that same general region of the island, and you get a real, concrete sense of just how much variation exists, even between eruptions happening on the exact same island, let alone the wild exaggeration implied by a headline suggesting planetary scale catastrophe. And speaking of Kilauea, it's worth clarifying something that often gets confused in exactly this kind of clickbait headline, since Hawaii's Big Island actually hosts multiple active volcanoes at once, and they don't all behave the same way or on the same timeline. As of this month, Kilauea, Mauna Loa's smaller but currently far more active neighbor, has actually been putting on a genuinely spectacular ongoing show, producing episodic fountaining eruptions right now, with its 51st distinct fountaining episode having just wrapped up on July the 15th of this year after more than 8 hours of continuous lava fountains, some reportedly topping 1,000 feet in height, visible from designated overlooks inside Hawaii Volcanoes National Park. This kind of episodic behavior, alternating between dramatic, hours-long bursts of fountaining and quieter periods of glow and steam in between, has actually become something of a signature pattern for Kilauea's current eruptive sequence, with each episode typically preceded by hours of detectable precursory activity, giving both scientists and park visitors a genuine, reliable heads-up window before fountains actually begin, allowing USGS to issue timely public alerts ahead of each new episode, rather than being caught off guard by sudden, unpredictable bursts of activity. That's genuinely exciting, visually dramatic volcanic activity happening on the very same island right now, but it's happening at Kilauea, not at Mauna Loa, and conflating the two, or implying that ongoing Kilauea activity somehow signals an imminent Mauna Loa eruption is exactly the kind of misleading shortcut that fuels headlines like the one bringing you to this video in the first place. Mauna Loa and Kilauea sit on the same broad hotspot system, but they maintain entirely separate magma plumbing, and one erupting says essentially nothing definitive about what the other is about to do. Now, does the fact that Mauna Loa is quietly inflating, slowly refilling its magma reservoir, mean an eruption is imminent or something to genuinely fear? Here's where it's worth understanding exactly how volcanologists interpret this kind of steady, unremarkable inflation, because it's actually a completely normal, expected part of a shield volcano's ordinary life cycle rather than some ominous warning sign. Mauna Loa has erupted 33 times since its first well-documented eruption back in 1843, meaning historically it erupts on average roughly once every 5 years, though the gaps between individual eruptions have varied considerably, sometimes coming just a year or two apart, and in at least one case, the 38-year gap preceding the 2022 eruption, stretching on for decades at a time. The kind of slow, steady summit inflation currently being tracked by USGS monitoring stations is exactly the process scientists expect to see happening in the years following any eruption. As magma rising from deep within the Earth's mantle gradually refills the reservoir that was partially drained during the previous eruptive episode. This monitoring effort itself is genuinely extensive and sophisticated. The Hawaiian Volcano Observatory maintains a dense network of seismometers to detect the subtle earthquakes generated by magma moving underground, continuous GPS stations to measure ground deformation down to fractions of an inch, and gas sensing equipment to track the chemical signature of volcanic emissions, all of it feeding into monthly public reports that lay out exactly what's currently happening beneath the surface in plain, measured language. Far from being a hidden secret or a sign the volcano is dangerously destabilizing, this is precisely the kind of activity the Hawaiian Volcano Observatory publishes in its own regular, publicly available, monthly updates, openly and matter-of-factly, specifically because it's considered routine, expected behavior, rather than a cause for alarm. It's genuinely worth understanding what would actually happen if and when Mauna Loa does eventually erupt again, since a realistic picture is honestly far more useful and honestly more compelling than an exaggerated one. Given the volcano's shield shape and consistently fluid lava, the greatest hazard isn't the kind of explosive ash-choked catastrophe that clickbait headlines love to imply. It's lava flow itself, fast-moving in some cases, historically reaching the coast in as little as 3 hours from the start of an eruption in past events, capable of covering significant ground and threatening infrastructure, homes and roads directly in its path. Exactly the kind of concrete, well-understood, historically documented hazard that Hawaiian emergency management agencies plan and prepare for continuously, using detailed hazard maps built from centuries of accumulated eruption history. Those hazard maps divide the entire island into numbered zones based on how frequently lava has historically covered each specific area and how directly each zone sits in the path of Mauna Loa's most active rift zones, giving residents, insurers, and county planners a genuinely data-driven way to assess risk for any given property. Information that's been refined and updated using more than a century and a half of carefully documented eruption history. The other significant hazard worth mentioning is VOG, a local term combining the words volcanic and fog, referring to a hazy, sulfur dioxide-laden air pollution that can drift downwind from an active eruption, posing genuine respiratory health risks for people with asthma or other lung conditions, even from a considerable distance away. A far more common and statistically significant health concern during any Hawaiian eruption than the lava flows themselves, which typically move slowly enough that evacuation, while genuinely disruptive, rarely poses a direct threat to human life when official guidance is followed. Scientists don't need to speculate wildly about what a future Mauna Loa eruption might look like, because they have an extensive historical record of past eruptions to draw on, along with continuous, sophisticated real-time monitoring specifically designed to provide meaningful advance warning well before lava actually starts flowing. Exactly the kind of warning that gave residents near the volcano weeks of lead time to prepare ahead of the 2022 eruption. So, to bring this all the way back to the headline that brought you here, Earth's biggest active volcano isn't about to crack the planet open, because that's simply not a real geological phenomenon. No eruption in the entire history of this planet, including far larger, more catastrophic events than anything Mauna Loa has ever produced, has ever come remotely close to threatening the physical integrity of Earth itself. A rocky planet nearly 8,000 miles in diameter is simply not vulnerable to that kind of damage from surface-level volcanic activity, no matter how large or how frequent that activity might be. To put that scale mismatch in perspective, even the very largest volcanic eruptions in Earth's deep geological past, events like the Siberian Traps eruptions roughly 250 million years ago, associated with one of the most severe mass extinctions in the planet's entire history, involved the release of an almost unimaginable volume of lava and gas over hundreds of thousands of years. And even an event of that genuinely civilization-ending magnitude never came close to physically cracking the planet apart. It reshaped the climate and the biosphere dramatically, but the solid rocky body of Earth itself remained entirely intact throughout. Mauna Loa, however large it may be relative to other volcanoes we're familiar with, produces eruptions that are, by comparison, almost vanishingly small on a genuinely planetary scale, releasing at most a fraction of a cubic mile of lava during any single eruptive episode, a quantity that, however locally significant for the communities living nearby, represents an infinitesimally tiny fraction of the total mass of the planet it emerged from. And what is genuinely true and genuinely worth paying attention to is that Mauna Loa remains an actively monitored, actively refilling volcano that will, at some point, whether that's next year or another decade from now, erupt again, sending fluid lava flowing across parts of the Big Island the way it has done 33 times since scientists started keeping careful records, an event that will be well forecast in advance, closely managed by experienced emergency planners, and based on the extensive historical record of exactly how this specific volcano behaves. Almost certainly survivable for anyone who follows the guidance of the scientists who have been watching this mountain patiently and carefully for generations.